This tutorial will show how the Auto Design option in CSICOL can select the required reinforcing or size the column based on parameters defined by the user. Initially, we will assume that our column size is fixed at 16 inches square and that only the rebar may be varied. To start, go to the new rectangular column option and specify that the width and depth are to be 16 inches. And although we are specifying the rebar, this is only to define a pattern, as a rebar pattern must always be defined when using the Auto Design option. The 12 number 5 specified here are completely arbitrary and will most likely change when the Auto Design is performed. We will also increase the concrete strength to F prime sub C equal to 5 KSI. Next, we will assign the column loads. The column will be loaded with 900 kips axial load, but will carry only a small moment of 40 kip feet in each direction. A check of the capacity ratio for the given column prior to performing the auto design shows that the ratio exceeds 1, and thus the initial 12 number 5's input for pattern definition are not acceptable and a redesign will need to be done. We start the redesign process by going to the column Auto Design command and clicking on the Auto Design Options button. CSICOL will select either the reinforcing or the size of the column, or both, but in this case we want the size of the column to remain at 16 inches square, so we'll shut off the size selection option. We will increase the maximum reinforcement ratio to 5%, but we'll ask the program to select based on rebar size. It is important that the check above ratio limits box be checked to ensure that the reinforcement selected is within the ratio, as the program does not automatically check any code ratio requirements. Now we can start the auto design. On the 5th iteration, the program has determined that number 9 bars will provide adequate capacity for our 16 by 16 inch column with a ratio of 4.69%. A check of the capacity ratio does indeed show that the ratio is now below 1 and therefore acceptable. And the display of the PM curve for the load combination confirms this. Next, we will increase the axial load to 1000 kips to see how the design changes. Again, we go to the column Auto Design command and start the auto design. This time the design could not be completed as maximum limits were reached. Go back to the auto design options and increase the maximum ratio of reinforcing to 6%. And rerun the auto design. This time the program has completed the design and determined that number 10 bars with a rebar ratio of nearly 6% will provide adequate capacity. Our last design will involve increasing the axial load once more, this time to 1200 kips. But rather than increasing the reinforcing, we will hold the reinforcing constant and have the program increase the size of the column. Select Do Not Increase Reinforcement and click on the check boxes for increased column height and width. As a side note, if both the rebar and column size are chosen to be increased, the program will alter the size of the column only if an adequate design cannot be reached during rebar selection. Start the auto design once more, and after 6 iterations, the program has completed the design with a 20-inch square column while keeping the reinforcing fixed at the same 12 number 10s. A check of the capacity ratio does indeed show that the column is acceptable with a ratio less than 1. This concludes this tutorial.